Welcome. Glad to see you all came. A nice crowd. So we'll get right into it and tuck in. Um, by the way, I'm coming to you from, oh, it's not there anymore. I'm coming to you from beautiful Edinburgh, Scotland, which is my new home. I'm very happy to be here. So what are we talking about? We're going to be talking about pair programming as peers, but let me help you out a little bit. A lot of the problems we get with it is that people either just personally don't want to do it because they picture something really awful, or they meet resistance where people say, well, it can't possibly be efficient. We're going to get a lot more done if we don't. So I wanted to arm you a little bit with some information and some perspective that will help you to perhaps get it started where you are. So there's a simple system. I know this probably looks ridiculously simple. This 5-step idea that we work with, that we start clean. And by that, we mean that we start with a clean repo, no changes locally, no files locally. Everything's exactly caught up with our branch. We tend to do trunk-based. And we do a git status. There's nothing unusual. We run all the tests in a build, so we know that it's clean, because otherwise, you end up spending half the day trying to solve a problem that you didn't create at some point. So clean start, that's our first step. And then we go to easy recovery, where we save and validate intermediate steps. So we have a blog at Industrial Logic on micro commits and how we use those. Basically, just save your game before a boss fight. And most fights are boss fights. So that's how we work. Again, we validate those with tests as we go, and we move on. Fast feedback. We want to make sure we're doing good work and doing it well. And that often means having more people eyes on while we're working, and having more validation mechanisms available, and getting the work in front of people who can give us, a thumbs up or a thumbs down. Well, working with our colleagues is a good way of getting there, especially when our colleagues aren't just like us. So there's a certain power to that. Of course, integration, continuous integration, and you've watched the Dave Farley videos, all this stuff. Real integration, where we actually do mix our code together many times a day, preferably at least once a day. All of our changes meet everybody else's changes, so we can fix things. And that's a good way of working. And that, with a bit of scripting, can make for safe releases. And I think most people get the idea that if we work clean and we work together, and yes, Brad, collective code ownership, absolutely, that we should be able to run this 5-step process fairly often and get it to work pretty well. I think a good day for us is about 12 to 20 releases to production, and a bad day is like 2 or 3. So I don't know what your numbers are like. You might have more people and more products and go out more often than we do. We're certainly not a record breaker. I think Netflix was going 300 times a day several years ago. So the question is, if that's, so simple, why isn't everybody doing it? Well, it is simple in theory, and as you know, simple things are hard. So what are we working with? Well, most places you file tickets, and then people pick up a ticket and work a ticket by themselves, and then they have to pass it off for some review and some testing and blah, blah, blah. Ticket processing is really common. It's probably the most common misunderstanding and incorrect implementation of Scrum on Earth, and you'll see it in many companies. So why does it not work, though? It seems like people are doing it, and they do eventually release software. Well, the problem is people. We're people. And the inside of our head is much smaller than the universe outside of our head. So let me give you some examples. Any one person in a company usually knows about 5%, maybe as much as 30 of the company's application code. I don't think that many people know all of the code that they're working with and all the code that their work touches. That's very rare. If you think about all the languages you use every day and all the tools, do you know 40% of every language that you use? Do you think that anybody knows 100% of their primary language and its libraries? Most people don't. No, not anywhere close. So maybe 40% of the skills they use every day, they have some mastery in. 30% of each language in use, maybe even less of the library. Peripherally aware of the deployment platform. What's your primary editor? Well, maybe you use JetBrains editors. Maybe you use Visual Studio, or maybe you use Vim. Do you know what all it can do? Of course not. It does a million things. There's an entire language built into Vim. What do you think that JetBrains is going to be like? There's so many options and so many configurations and plugins. We don't know. And a typical user may have once met an end user. Maybe. That's what you're working with, right? So what happens? Well, individuals make some mistakes. It's perfectly reasonable, especially when you consider, like, okay, how much do you know about accessibility? Does anybody here know all of accessibility and security and observability? Does anyone know all of CSS4, HTML5, React 18? How are you on your Azure skills and your GCP and Heroku? Do you know all of Kubernetes? How much do you know about your deployment pipeline? Do you know the entire operating system you develop on or that you deploy to? No, of course not. You don't. You don't know that stuff. And why not? Well, here's just 2 years of Java. Every one of these numbers you see over here is a release. That's just 2 years. Just 2 years. Right? That many releases. Well, okay, but that's an old stable language, isn't it? Yeah, kind of clunky old stable language, but it keeps changing. How about JavaScript? Well, this version of the book is a 7th publication. It's 600 pages long. JavaScript was released 4 times since the 7th publication of the book. I think it's got a couple more out now. 83 modules in the ES6 standard library, over 200 modules in Python. And do you know all your JavaScript frameworks? Well, okay, look, I'm just making web components. How hard can that be, right? Okay, here's 50 ways to make web components. It's actually over 50. By the way, this isn't current. This was 2 years ago. There's more now. Right? How many of those do you know? Well, you probably only need to know one. Well, how much of one do you need to know? Well, I only know about 20 or 30% of the one I know, or the 2. It's a tough game. So there's more to deal with than any human being has the capacity to hold. And it changes faster than they have the ability to keep up. By the way, do you read the what's new in Python, what's new in Java, what's new in C#? I recommend those. You should read them. If you can find the time to skim that and see what you don't know and pick up on those are really good. The release notes are valuable. And maybe when you release things, you can write release notes as good as those. What's new in my app? Well, if it's too much, realize that we didn't start talking about test frameworks, ticket trackers, project management tools, dashboards. So what we find is a bunch of people who are working in a shallow hurry. There's a huge demand for our services. People want things released. People have schedules. And people rush to get by or muddle through without wasting their time in learning how to work properly in the stack that they work in. And I'm not making fun of people to say that, because I do the same. It is one of those things that we don't know the actual investment it'll take to learn to do things well. So shallow hurries away. By the way, the other phrasing of that is working in intentional ignorance. That sounds horrible, but it is a thing that happens. It's true, right? So people will try to get by with what they already know and not have to learn new things to get the job done so they can be quick about it, even though we know learning helps us be quicker at all the future jobs. So in light of all of this, why do so many people insist that programmers and testers should work alone? What's the basis of should? Is there a moral, ethical, or pragmatic basis that people should work alone? Well, they should be able to. Well, why? Why is that a desirable state? Well, because it's easier to measure individuals if they work alone. Yes, but it's harder to release software. What do you want to do? Are we in the business of measuring people or releasing great software? We have to sometimes make a choice in that regard. It's a tough game. But, people do work alone. And of course, if they work alone, you can't trust them to not make a mistake, right? So, yeah, of course, you have to have an inspection and a tester and an integrator and, well, okay, fine. If we go back to the 60s and 70s, we'll find someone who's very dear to my heart, the work of W. Edwards Deming, right? What is our system? Well, we make things and inspect them, which if applied to making toast would be, you burn it, I'll scrape it. Well, why do we keep burning toast? Well, because individuals burn toast. Well, why are they working as individuals? So that we can measure how much toast they burn and promote the ones that burn less toast. Well, why don't we not burn the toast? Oh, well, that would be too hard, and it's not the way our system is set up. It's difficult. It's very hard. So let's go back and look at this again. People aren't stupid. It's just they don't know better yet, right? I mean, it seems reasonable. It's what everybody else is doing. You borrow other people's processes because at least you won't be alone. And if it's stupid, it's not your fault, right? So we try to take things that we know and apply them where we are. But we know this as a fact. Wherever there is a handoff, there is a queue. If I'm going to give Brandon something to do, it's going to go on the pile until he can get around to it. Reasonable. If the person who's the consumer of the queue is busy, then every queue has a wait. How long does it take you to get a PR? Is the person doing PRs also writing code and waiting for their PR? Are they in meetings? Are they busy? What's the normal time? Well, I'm told that an industry standard is 5 days. I think that's way too long. I don't know anybody who waits 5 days to get a turnaround for a code inspection. But maybe you do. I'm not saying it's wrong. I'm just saying it's not good. It's true, not happy. Okay, what does your process look like? Can you list all of the queues and handoffs to all the busy people that are involved? What would be the quickest time, considering how fast the green worker works and the number of items in their queue? If I put something in as a yellow developer today, how long would it take to drain that queue and then drain out of the blue queue and then drain out of the red queue and make it to production? And is that less than 2 weeks? Can we guarantee that? And are all those people really busy? Well, yes, of course they're all busy. The standard procedure is to keep everyone as busy as possible so they can't serve their queues very well. Lead time is largely queuing time. We tend to find most work spends 95% of its life waiting for a human being. Now, Don Reinertson, who did the Lean Startup, he gave us a great video, or a visualization of this. He has these two teams, the red team and the green team. And as you see, the green team has very quick handoffs and they win by a considerable margin. But I also want you to notice that every single runner on the red team is faster than any of the runners on the green team. Well, why are they so far behind? Because for some period of time, the baton is not moving. Now, if developer time is 5% of the total time it takes to get an idea from a green light to production, if 5% of that is development time, how much time could you save if the programmers could work twice as fast? Pretty dubious. 2.5% maximum improvement, and it's unlikely. How much time could you save by eliminating 2 queues or 1 queue? You might find that to be much more significant. In fact, quite often people can get done faster if the programmers take twice as long to get their work done. That doesn't sound right, I know, but bear with me for a second. Worry about the work being blocked, not the people being idle. Keep the baton, the work, in continuous motion. So why does that work for the programmer to take longer and be done sooner? Well, okay, what happens if work has to return? Well, Does the programmer immediately, are they sitting idle waiting for the review or the testing? Of course not. There's a queue with a busy person. So the question is, how long does that round trip take? So if I send it off for testing and it comes back, what's the period of that? I'm going to be doing new work in the meantime. The return is going to interrupt my work, or my work is going to delay the rework of the older ticket that is just decaying by the day, hoping to get it into the main branch before it becomes incompatible due to all the changes. Well, what is the time on that? And if we're there, let's go with this. Your loops tend to nest. So if blue rejects my work, doesn't it have to go through purple again? And if it goes through purple, doesn't it have to go through red again? Oh, yes. Race, road, lean, startup, Grinderson road principles. Thank you for that, Brad. I hate to be wrong, but you are right and I was wrong, and I'm glad to correct. So now next question is, how many rejections will a piece of work get? Because if you can't answer how many rejections and at which points, then you cannot tell me how long that piece of work will take to get finished. You have no idea. And you can have no idea. That's disturbing. But then let's make it worse. Tim, how can it be worse? Easy. Let's take a piece of work and split it into partial, incomplete, parallel jobs and give them to different people. And let's not do that with one job. Let's do it simultaneously with all of the jobs. And then when all of the people who get all of the pieces all finish their pieces at the end, we'll integrate it all together. And in the meantime, quick question. How long will it take for this piece of work to get finished? How close is it to being done? And when can we expect it? Well, that depends on who has the pieces and if it's at the front of their queue or the back of their queue. And of course, if anything gets rejected, that might go in front of our work. And any other kind of interruptions can delay them finishing the piece of the work that we're looking for, if they're out of office, if they're sick. By the way, one of my clients had a person out for 2 months, and when they came back, none of the work had been progressed by anyone else. Everything sat for 2 months that they were out. Nothing progressed. Disturbing. Well, okay, now I have this situation, and I have multiple stories. I don't know when any of them are going to be done, and I don't know how many times they'll be rejected or to whom when they fail. I don't know how many nested loops I have. So is this the most predictable way for us to reduce our lead time and make frequent high quality releases? Well, no, seems like a way that people have built to avoid making software work. So Ashley Johnson asks us, which is worse, people waiting on work or work waiting on people? That could be our meditation. So how can we raise the individual situational awareness and thereby accelerate delivery? Well, as we mentioned, it's probably not even a good idea, right? Probably what we want to do is eliminate round trips and rejections and queues. But okay, well, let's say that we want to improve an individual's ability. Again, that's that 5%. We'd like to come to 2.5% improvement on that, faster on the overall process, whatever difference that makes. Well, we do find that tools matter, right? You've seen this. You fire up an editor that has good semantic editing. Maybe it has color syntax highlighting that maybe can do refactoring and test running and things for you. And those can help, right? Can augment an individual. Okay, we're okay with that. How about code checkers? Do we use things like Sonar Lint? And they're like, well, sure, why not? Now, a lot of people turn them off. First thing they do is disable all the plugins and have no checks until they think they're all the way done. I think that's troublesome. I think that people waiting to work is a good thing. I think work waiting on people is a bad thing. And if people can get the work done quickly, it's going to be pretty powerful. So we don't shy away from the code checkers because we don't want to make mistakes now and find out about them later. We want to write good code now so that it doesn't return to us later. We probably want to know often and frequently that we're in the right place. By the way, our tools have been trying to educate us on their use all along. And they have this thing. Here's a pop-up, tip of the day, and it gives you the option, don't show the tips. Don't tell me how to use the editor better. How many people don't disable the tip of the day? You want to give me a thumbs up if you haven't disabled your tip of the day? I don't disable mine. I actually read them. A few people, most people, I find they turn them off because they're afraid they will have to learn while they're trying to get other work done. It's a disturbing thought. So we could do that. Learning at the moment of relevance. By the way, one of the things, I have no relationship with SonarLint except I like it. The SonarLint I like. SonarQube, maybe not so much. By the way, I wrote a Vim book. If you ever want to look it up, I can talk to you about it later. SonarLint is nice. And one of the things it'll do is when it gives you a warning, you can click on it and it'll take you to the page where it explains what the problem is, gives a bad example and a good example so you can compare and learn on the fly, which I think, man, all the tools should do that. They put a lot of time and effort into that element, and I wish I could build it into our stuff. But if all those scans are pretty useful, the problem is none of them understand your application. So you're going to have to build your own application scanner. And how do you do that? Microtests. The tests you write and run, a fast test suite that runs frequently while you're editing and tells you this piece of code no longer works, can save you hours of going in the wrong direction before you come back. But Tim, these are all personal. Yeah, I know these are all personal. We'll move forward a little bit more. What about artificial intelligence? Everybody's excited about AI, right? Hey, what if I have AI and FlexiLint and Veracode and SonarLint and syntax highlighting and JetBrains and all of these things helping me write better code? And then the AI could come along and say, hey, here's how you would write this code, right? That would be great. Most people don't have a problem with that. Okay, my dear friends. How about actual intelligence? What if we collected up the people who know the work? The people who know the parts of the code that we don't know, who know parts of the language and the library and the editor that we don't know. What if we just collected some human beings with actual intelligence and we thought through a problem together and we built the solution together? That can take a lot of different forms. Pair programming is one. Pair programming is, by the way, enjoyable. It's exciting. It helps us stay focused. We have continuous review while we're coding. You can see other people's changes. We do this with mob programming too. Mob programming is just pair programming for a group. It's less intense. It's more comfortable. If you think about pair programming relationally as a date, think about mob programming as going to a party with your friends. It's much less personal, right? And the abuse potential is way down. If someone is being a jerk to you and you're pair programming, you're kind of stuck. Or if they're freeloading, or if they're being bossy. What happens when there's 5 of you? Well, they're not going to get away with that. They're not going to freeload. They're not going to be bosses, and they're not going to be abusive. They can't get away with that with the whole group, right? And, people pay attention. So by focusing the skills of multiple people on one job, we bring real intelligence to bear. If artificial intelligence and artificial scanners and artificial intelligence in our tools and syntax highlighting, if those things are helpful to us, bearing that more intelligence to make better choices, why is actual intelligence bad? And why is writing tests a chore? Well, we could talk about the rules of pair programming and the experience. I will drop this one nugget. All of the studies for ensemble programming of all sorts, pair programming, mob programming, and swarming. People who have not done it on entry have 80% or more have said that they expected it to be miserable. On the way out of the studies that have been done, over 90% prefer working in an ensemble or a pair to any other way of working. I think that it's bad marketing. Imagine that you had to convince people that soda tastes sweet and they didn't believe you. It would be a difficult sell. But what if we look at this? Us as individuals alone are just not enough. The world's too big, the code's too big, but us as a group gives us a lot of safety and hedge against all of that. So I would say that pair programming is a way to bring actual intelligence to bear on today's problems and issues and features. And also, by the way, to spot problems that would keep you from doing things like worldwide outages because the file was formatted incorrectly and you never thought to test the file reader to see how it handles bad formats. Not that that's ever happened in the real world. And that leaves you with the question is, what do you really need in order to build quality systems release after release and time after time? And with that, I think we can open this up to questions and discussion.